Welcome back. Today we are going to look at section 2.8. Our target today is to be able to graph two variable inequalities. We're going to start with just linear inequalities. It's a two variable inequality whose graph is a region of the coordinate plane bounded by a line. Solutions to linear inequalities are represented by a shaded region. So instead of just graphing a line, we're actually going to graph a line and then we're going to shade one side of it. So our line is called the boundary, and then the shaded part is called a half plane. It's half of the coordinate plane. You are either shading above the line or below the line. To do these graphs, we're going to convert our equation into y equals mx plus b form, into that slope-intercept form, and then we're going to graph the line. We use a dashed or dotted line for symbols less than or greater than. If there's an equal sign, then we have a solid line. Once we have our boundary line drawn in, we are going to look at how do we shade, which half of that coordinate plane do we shade. And if it's in this y equals mx plus b form, then we can follow this rule. We shade above the line if it's greater than or equal to. We shade below the line if it has to be less than or equal to. So let's try one. Our first equation is already in slope-intercept form, so we can go ahead and start graphing. Our y-intercept is -1, so we're going to put a dot at -1, and we're going to use the 3 here as our slope, so up 3 and to the right 1. Up 3 and to the right 1. Then we look at our inequality symbol. Since there is an equal sign on it, we are going to use a solid line. Make sure your line has arrows on the end. And then we focus on the less than part. Because it's less than, we want to be underneath our line. So values that would be underneath the line would be everything in this half of our coordinate plane. All right, let's try the next one. This time it says y has to be greater than -1/2. There should be an x there. Sorry about that. -1/2 x plus 7. Our y-intercept is our 7. So let's put a dot at 7. And then we're going to do a -1/2 slope. So down 1, right 2. Down 1, right 2. Down 1, right 2. Looking at our inequality symbol, we have a greater than, but there's no equal sign. So we are going to do a dotted line through these points, arrows on the end. And then to determine the half plane that we're going to shade, we look at whether it's greater than or less than. In this case, it is greater than. Because of greater than, we want to be above the line. So we're looking at values up there. Now, if you're not sure that you've shaded it correctly, you can always test a point. For example, let's say we test this point. Okay? It's in our shaded region, so it should work. So if we plug a 2 in, our x value is 2, our y value is 0, does it work? All right, so our equation was y is less than or equal to 3x minus 1. We are plugging in a 2 for x and a 0 for y. That's the coordinates, 2, 0. Is it a true statement? Well, on the right side, we've got 3 times 2 is 6, minus 1 is 5. Is 0 less than or equal to 5? Since that's true, it means that all of the points on that side of my line should work. So we have shaded the correct side. All right. Think back to the first part of this chapter. When we graphed x equals 4, we had a vertical line. The only difference here is because there's no equal sign, it's going to be a dotted line. So we want a dotted line for x being 4, arrows on the end. And then we want our x values to be greater than 4. So if you think about in your coordinate plane, x values bigger than 4 would be things like 5, 6, 7, 8, the right side. So we're going to shade the right side. All right, now notice on this next one, it is not in slope-intercept form, it's in standard form. So let's go ahead and convert it. We have negative 3x plus 2y is less than or equal to 8. We're going to add the 3x over to the other side. So we have 2y is less than or equal to 3x plus 8. And then we're going to divide everything by 2. So my new inequality is y is less than or equal to 3/2 x plus 4. So I'm going to start at the y-intercept of 4, and I'm going to do a 3 over 2. So I'm going to rise 3, run 2 for my slope, rise 3, run 2. There is an equal sign on this one, so I'm going to do a solid line. And then in terms of shading, we have to look at the slope-intercept version. It says y is supposed to be less than that, so we want to be underneath our line. So we would be shading everything under here. Again, we could test a point. Let's say we try this point, over 1, up 2. We put a 1 in for x, we put a 2 in for y. So we've got negative 3 times 1, 2 times 2. Negative 3 plus the 4 is 1. Is 1 less than or equal to 8? It is, so we know we shaded the correct side. If we had tried that point and it didn't work, then we know we shaded the wrong side, and we'd have to change that to the opposite section. Our next two are just the reverse. I'm going to give you the inequalities picture, the graph of it, and you are going to give me the equation or the inequality for it. So the key things that we had to find is our y-intercept and our slope. Okay, for this one, it looks like it's touching the y-axis here at negative 1. And if we look at our slope, find a couple points where we hit nice corners of our graph paper, it looks like we're rising 3 and running 1. So my slope would be 3. So if this was just a plain line, my equation would be y equals slope times x plus my intercept, which is negative 1. But this isn't just a plain line. It has a dotted line to it, which means it's not actually touching on that line. It's just really close to that boundary. So we know that we're going to have to take the equal sign off of my inequality. And then I have to look at which side was shaded. Since they've shaded underneath the line, I know that I want to be less than. So strictly less than, since it's dotted and shaded underneath. For our next one, our y-intercept here is negative 6. Our slope, it looks like we're moving down 1 over 1. So we have a slope of 1. We have a y-intercept of negative 6. So we'd say y equals 1x minus 6. Because it's a solid line, we're going to have an equal sign. And because we're underneath that line, we are going to be less than. All right, our last example says you're going to the fair to go on the rides. You don't want to spend more than $15. Tickets are 25 cents. The small rides require 3 tickets and the larger rides require 5 tickets. How many small or large rides could we go on? So the first thing we want to do is identify our variables. I'm going to let x be the number of small rides and y be the number of large rides. They're asking us to figure out both of those. We are given information about how many tickets are required. So let's figure out how many tickets could we buy. It says we don't want to spend more than $15. So let's say we spend exactly $15 and tickets are 25 cents. So 25 cents for each ticket, and we don't want to go over 15. All right, if we divide by 0.25, we should get t equaling 60. That means we can buy a maximum of 60 tickets if we don't want to go over that $15 mark. All right, let's look at how many tickets are required for each ride. For each one of my small rides, I need 3 tickets. For each of my larger rides, I need 5. So 3x represents the number of tickets I would spend on the small rides. 5y represents the number of tickets I'd spend on the larger rides. Together, my total number of tickets can't be over 60. That's the maximum I was allowed to buy with my $15. All right, let's look at a graph of this. Now this is in standard form. So a real quick way, remember, to graph standard form is to find those two intercepts. If we put a 0 in for y, we've got 3x equaling 60, so x would have to be 20. If we put a 0 in for x, we have the equation 5y equals 60. Dividing by 5, we get a 12. Now those are going to be the maximums. So let's let our x's down here. Okay, number of small rides. Our y value is the number of large rides. Okay, and we know that we're going to hit at 20, 0. All right, so 20 is right here. And the y-intercept was 12. We land there. Now, technically, we would be filling this region with just a whole bunch of little dots because we can't have half of a ticket or half of a ride. So it would technically be what we call a discrete situation where we would say I can go on any of these combinations. However, that's a lot of dots to plot. So what we do is we just shade it. We said it could be less than or equal to 60, so we're going to do a solid line connecting our intercepts, and we want to shade all of the values underneath here. All right, now to double check, could I go on 5 small rides and no large rides? Well, if I put a 5 in here and a 0 for large, I get 15 plus 0 is less than 60, which is true, so we have shaded the correct section of our graph. All right, so key things to focus on here. You're going to graph the line. Typically, we like it in that y equals mx plus b form. Just makes it a little easier to graph and to tell which side we shade. So you're going to graph the line using slope and intercept. You're going to make it dotted. If there's no equal sign, you're going to make it a solid line if there is an equal sign with your inequality. If your y values have to be less than or equal to, you're going to shade under the line. If your y values are greater than or equal to, you're going to shade above the line. And remember, you can always test a point. If you try a point in the region that you've shaded and it doesn't appear to work, that means none of the points in that shaded region would work, and you've shaded the incorrect region.